Hi folks, we're going to take a look at the solution from number 4 from Unit 7, Lesson 7. And so they're asking us to solve this system of equations. Okay, so I'm going to solve this using matrices. So first thing I'll do is I'll put this into a matrix. Okay, so I already have an x coefficient which is equal to 1, so I'll leave the order as is. So 1, -2, 3, and here 1. Okay, here we have 2, -3, 4, and -2, and here we have -1. So be careful because there's no y variable, so that means the coefficient is equal to 0. So put a 0 there, 1 and 7. Okay, so again, the way we solve this is to start by eliminating these coefficients of x in rows 2 and 3. Okay, so here I'm going to take -2r1 plus r2 and replace r2 with that. Okay, and then here I just need to take r1 plus r3, and that will replace r3. Okay, so here, first row won't change, -2, 3, and 1. Okay, so here we have -2 plus 2 is 0. Here we have 4 minus 3 is 1. Here we have -6 plus 4 is -2. And here we have -2 minus 2 is -4. Okay, and now for the next row, we've got 1 minus 1 is 0. Here we have -2 minus 0 is -2. Here we have 3 plus 1 is 4. And then here we have 1 plus 7 is 8. Okay, and now I want to go and get my 0 right here. So I'm going to take 2r2 plus r3, and that will replace row 3. Okay, and let's see what happens. I think you can see where this is going. 1, -2, 3, and 1. Okay, so 0, 1, -2, -4. You see the way I talk it out as I'm writing it out? So you should be doing that in your head to avoid little silly mistakes like forgetting a negative or when you're doing the additions. Okay, so here we have, well, 2 times 0 plus 0, of course, is just 0. Here we have 2 minus 2 is 0. Here we have -4 plus 4 is again 0. And here we have -8 plus 8, which is again 0. Okay, so this row of zeros here tells us that we're going to have infinitely many solutions. Okay, now even though they're not asking us for geometric interpretation, we might as well use that to help us know what our answer should look like. Because the infinitely many solutions geometrically, because none of the planes are parallel, we know that this is going to intersect in a line. Okay, so our solutions are going to look like the equation of a line. And so we're going to use these two equations to come up with the equation of a line. So let me start with row 2. I can rewrite that as y minus 2z equals -4. So remember that when we're finding the equation of a line, the trick is to write two of the variables in terms of the other. So here I either write y in terms of z or z in terms of y, and it's a lot easier to isolate the y. So y can be written as 2z minus 4. So the goal is to now write x in terms of z. So I do that by substituting it back into the first equation. So this row here represents x, okay, minus 2y, but of course y we just wrote as 2z minus 4, okay, plus 3z equals 1. And now I can solve and write x in terms of z. So we have x minus 4z plus 8 plus 3z equals 1. So x equals, so this is -4 plus 3 is -1. Bring it to the other side, becomes +1. And then we have 1 minus 8, so -7. Okay, and so once we've written two of the variables in terms of the third, that third now becomes our parameter. So I'll let z equals t, and so the answer can be given as x equals t minus 7, okay, y equals 2t minus 4, and z is equal to t, and t can take on any real number. Okay, so here's our infinitely many solutions, and if we wanted to give this a geometric interpretation, we know that this represents the equation of a line. Okay, so again, to recap, if you're using matrices, you want that 1 in the top left corner if at all possible. You reduce the matrix, and it turns out that this row of zeros implied that we had infinitely many solutions. Now, let's say you were solving this using elimination. Well, again, you use the same idea of eliminating the same variable twice. So if you were to eliminate, say, the x's from 1 and 2 and then using 1 and 3, or even, I don't know why you'd do it, but let's say, I guess, the z's from 1 and 2 and 3 and 1 and 3, you could easily eliminate the z's. Okay, what you should end up with is equations that are going to give you 0 equals 0 when you simplify or when you add them together. Okay, so that's it for this one.